Welcome to Riverina Institute, TAFE New South Wales of course, the Ohms Law practical exercise. So what we're going to have is we're going to wire up another simple series circuit with a resistor, a couple of different resistors. So for this particular power supply, I'm going to run the power supply around 18 volts. The resistors I'm going to use, I've got a couple of different resistors here. I've got a 150 ohm resistor, so the size 150 ohm, and an unknown resistor. And the unknown resistor is R3, so R3. We'll go through that. And we've got a couple of parameters there to write in, which you can do at your leisure. So turning page over, I've got a risk assessment which you'll have to carry out mandatorily in class before you start this practical exercise. And then we've got the procedure. You can read through that procedure, but we'll get straight into wiring it. This is something you'll have to do before doing this prac. So we've got the DC power supply, the fuse, the switch, the ammeter, the resistor, and the voltmeter. So let's wire that one up. Same thing as before, got the red connection into the fuse. From the fuse into the switch. Turn the switch off, into the switch. From the other side of the switch into the positive of the ammeter. So switch into the positive of the ammeter, and we're going to use the fluke again, ammeter. We come out of the ammeter into the resistor, so out of the ammeter into the resistor. So to start with, we use the 150 ohm resistor. I'll write that down. So that's a 150 ohm resistor, and the other side of the resistor goes back to home. So other side of the resistor, back to home. The only thing we haven't put in at this stage is the voltmeter, which goes in parallel or across the load. So the voltmeter now goes across the load, because we want to measure the voltage across the resistor, which is the load. So we got the red lead, we go into the volts into the positive. Okay, the positive side is connected through the ammeter, that's positive, into there, and that's negative, into the negative of the power supply. So this is the positive lead here, okay, and the negative lead of the voltmeter into the negative lead, which goes back to home. So I'll put that in voltage, put this around the current. So that's our circuit wired. Now before I start, we should do a couple of calculations, and this is something that we should be familiar with, you should have done. So, as we know, Ohm's law is voltage is equal to the product of current times resistance, or the VIR triangle. Scratch it as what it is. So, VIR. V, voltage is equal to the current times the resistance. Current in amps, resistance in ohms, voltage in volts. So, what we can calculate here is what type of current. If we transpose that formula, we can, with a 150 ohm resistor, and my power supply was 18 volts, if you recall, we should be able to estimate or calculate the amount of current we're going to see. So if I hold my finger over the I is equal to V over R. So we'll rewrite that formula. I is equal to V over R, which is equal to the voltage from my power supply is going to be 18 volts, divided by the resistance, and the resistance is 150 ohms. So 150 ohms. That's equal to, so bring into play a trusty calculator. We've got 18 divided by 150 is equal to 0.12 of an amp. Okay, remember the answer is in amps. 0.12 of an amp. Or that can also be written as milliamps, which you move 3 places, 1, 2, 3, which is also equal to 120 milliamps. But our particular meter is going to read it in amps, 0.12. So let's check that out. Should we see that? Let's hope so. So I've got my switch off, so I'll turn on the power supply. I'm going to wind my power supply up to 18 volts, that's voltage there. And I can write it over here, 18 volts, and it's as per the Prac. So I'll wind this up to 18 volts. So I'm at 18 volts, okay, 150 ohm current. So I'll turn the switch on, and I've got 17.5 volts across the load, okay, 18 volts from the power supply, and 0.119 of an amp. So almost 0.12 of an amp. In actual fact, if I could creep it, I can do a bit of a cheat here. 0.12 of an amp, okay, 17.7 volts, so close enough to 18, 150 ohms. So that actually works exactly as per Ohm's law. Okay, I'll turn that off. Now the other thing, I can unplug this resistor, and I can introduce an unknown resistor. In this particular case, it's R3. So I'll plug that in exactly the same way. Remember, a resistor can plug into either hole. It can go, doesn't really matter which way it goes in, that way or that way. But keeping it simple, plug it in like that. So we come out of here, okay, back to home. Exactly the same as the last resistor. Now, working that through, we can use Ohm's law to find out the value of this resistor. So, by using my meters, by calculating or reading the current on this meter, by reading the voltage on this voltmeter, I can work out the resistance of that resistor. So the unknown quantity in this particular case is R3. So if I cover up R on my triangle, R is equal to V divided by I. So R3 is equal to voltage divided by current, which is equal to, well, what is the voltage, what is the current? Well, that's what we're going to find out. Turn that switch off. I'll turn the power supply back on. I've got 18 volts again, okay, but realistically we want to read the voltage across the resistor here and the current, but we know we've got 18 volts going into the circuit. So I'll turn the switch back on, and my voltage reading across this resistor is 17.7 volts. My current is 0.551 of an amp. So to write that down, I've got 17.7 volts divided by 0.551 is equal to, let's plug it in, 17.7 divided by 0.551 is equal to 32.12. So we'll say 32 ohms. We use the omega symbol for ohms, as we know. So 32 ohms, or thereabouts, approximately, give or take. Obviously there's some tolerances in there, which you'll see as you work through this practical exercise. Just here there's some tolerance which you're expected to calculate, so it's not going to be an exact reading. The other things you'll do is you'll get some different values of currents, work out some voltages, and have some different resistances there. So 32 ohms. Let's check that though. That's what I've calculated. So I can turn this power supply off. I can actually unplug this resistor, and keeping in mind that the voltmeter I'm using is a multimeter, which means it measures voltage, current, amps and resistance. It measures three things, hence the term multimeter. So if I put it into ohms, okay, I'll plug the leads in to make sure it measures 0 ohms. Thereabouts it is 0. I'll null this meter out. So it's 0 ohms. Unplug. The theory is I should be reading 32 ohms. Let's have a look. 32 ohms. That's what I calculated, 32 ohms, and the actual resistor is 32 ohms. So once again we've been able to prove that Ohm's law, if you know two things, you can figure out the third. If you know two things, you can figure out the third. If you know two things, you can figure out the third. And thus concludes Ohm's law practical.